2004 part B. Oh, sorry, 2005 part B, excuse me. A string is of natural length A and elastic constant K is fixed to one end of a point O on a smooth horizontal table. String connected to of natural length A fixed at one end to a smooth horizontal table. The particle of mass m is attached to the other end of the string. Initially the particle is held at rest on the table a distance 2 away from 0 and is then released. Show that the time taken for a particle to reach O is root m over k 1 plus pi over 2. Okay, that's interesting. Okay, so we have here is a table. We also have a particle m. Does it say the table has friction or is it a smooth table? Smooth table, no friction. Okay, so this is the natural length. So this is the natural length point. Okay, we'll just call it the natural point. Can anybody tell me what happens at the natural point? What happens if the string is not slack whatsoever? Is there any force pulling you back? There's no tension, so it means force equals 0 at this point. It means that there is no simple harmonic motion beyond that point. Simple harmonic motion can take place, and then once it goes through here, all bets are off. It doesn't obey the other side. Okay? So, force is entirely due to tension. Force equals minus t. Why did I say minus tension? Because the x value is the displacement is to the right, and the tension is dragging it back to the left. They're in opposite directions to each other. So, force equals ma. Ma equals minus k times extension. Would you agree with that? Extension. Extension is its current distance minus its natural length. Okay? So, ma, we have to prove that it obeys probably simple harmonic motion first. Okay? So I'll say is ma equals minus kx, where x is the extension. Okay? So if this is the natural length, the x is the extension. I'll just call it extension as opposed to displacement, just for this one question. Okay, so x is the extension. So what does that make? Tension equals minus kx. Perfect, right? So a equals minus k over m times x. A equals minus omega squared x. What does that mean for omega squared? Omega squared is k over m. Omega equals root k over m. So we found out what omega is pretty quickly. It's sort of the upside down version of what's here. So we know we've made a good step there. Okay. What's the amplitude of the motion, guys? What's the furthest we're away from the natural length where there's no force? How far? So this is distance a. From here to here is a. It says that in the question. Natural length is a. Then what does it say about when we held at rest 2a away? So that's going to be another distance a. So the amplitude equals small a. Everybody get that? Okay. So this is 2a instead of release. Show for the time taken to reach O is root m over k plus 1. So what happens is with simple harmonic motion, we're going to do two things. We're going to have simple harmonic motion system set up like this with a central part here. And here's our particle 2a away. Now what's going to happen is, usually to complete a full oscillation, it'll go all the way out here and all the way back. Would everybody agree with that? That's the period of the motion. We're only going to cover here to here, which is 1/4 of the period. Would everybody happy enough with that? So the period is 2 pi over omega. T equals 2 pi divided by root k over m. T equals 2 pi m over k. That's the full period. We're only going to cover 1/4 of the period. So what's 1/4 of that? 1/4 t? Just going to be pi over 2 root m over k. The next thing to realize is that when we reach this point here and the string goes slack, what happens here? It now obeys linear motion, UVAST. U-V-A-S-T. The center of your motion is what, guys? The center of your motion? Dear God. The center of your motion is what? The center of your motion is where you have your biggest velocity, your Vmax. Please remember that Vmax equals mu A. Okay? So, your initial velocity is going to be what, guys? Mu A. Your final velocity, is there anything slowing it down? Is there any friction? No. So actually, it's just going to be a distance over time question, isn't it? Distance over time. So what's the distance we have to cover? Is A. How fast are we doing it? We're doing it by omega A, aren't we? So Vmax equals omega A, which is amplitude is small a. So it's going to be distance over A, which is going to be, oh, one thing. Distance over speed, excuse me. The speed is mu A. So the time is distance over speed. So that's going to be 1 over omega. And what is 1 over omega? It's 1 over square root of k over m, which is root m over k. Combine both answers together, and you're going to get root m over k plus, what's it, a quarter, plus pi over 2 root m over k. Factorize root m over k, and you get 1 plus pi over 2. And that's what you're asked to prove there.